Beta, we have actually calculated the electrode potential by using Nernst equation in the last class. Today, we are going to calculate the cell potential, of course, by using the Nernst equation. Suppose I have an equation where A moles of A is reacting with B moles of B, and it is giving C moles of C and D moles of D, where small a, b, c, d are nothing but they are basically the stoichiometric coefficients. Now, if I'll try to apply the Nernst equation over here, the formula is E of the cell is equal to E naught of cathode minus E naught of anode, of course that is E naught of the cell, minus 2.303 RT by NF log product of the active molar concentration of the product, as you can see, product of the active molar concentration of the product to that of the active molar concentration of the reactants, each raised to the power of the stoichiometric coefficient as represented by a balanced chemical equation. Now, what I can do right now is I can write down this equation in this way, which I have written, or I can actually write this as E of the cell is equal to E naught of the cell minus, I have already told you, 2.303 RT by NF. If I'm talking about this term, that is this term 2.303 RT by F, I have already told you this term is nothing but it is 0.0591 divided by number of electron change log, of course, product of the active molar concentration of the product to that of the active molar concentration of the reactant, each raised to the power of the stoichiometric coefficient as represented by a balanced chemical equation. Now, this is one formula which of course you have to commit to memory. There is another formula which I can actually apply, and that is E of the cell is equal to, of course, E naught of the cell minus 0.0591 divided by number of electron change log the species which is got oxidized, yani oxidation, divided by the one which is reduced. This is also one of the formula that I can actually use in order to calculate the Nernst equation or cell potential by using the Nernst equation. I have seen some books, they used to write in what way? They write down the same formula, but E of the cell will be equal to E naught of the cell plus 0.0591 divided by N log, in spite of oxidation divided by reduction. Now it become reduction divided by oxidation. So one and only the same thing. So you apply this formula, that formula, or any other formula will not make any difference. Nernst equation can be applied or can be calculated by using this formula also. Let us start with few questions, right? That will give you a better idea. Now, I am going to start with the back exercise question. Of course, that back exercise question is nothing but it is your 3.5. That is the back question that we have to take up right now. The question is Mg in solid phase change Mg to positive. This is 0.001 molar. Of course, if you shift 1, 2, 3, that is 10 ki power minus 3 molar. And salt bridge copper to positive 0.001 molar, 1, 2, 3, 4. That means 10 ki power minus 4 molar oblique copper in solid. I thought I have already given you a shortcut called lone. That means left oxidation, anode negative. Anode is negative, and this is PCRR, that is positive cathode right reduction. So if I write down here the oxidation half cell, magnesium in solid will give you Mg2 positive. Magnesium will go into Mg2 positive to show oxidation. So magnesium in solid will give you Mg2 positive. Of course, that is 10 ki power minus 3 molar plus 2 electrons. And then copper 2 positive goes to copper in solid. That means copper 2 positive goes to copper in solid. So Mg in solid will give you, copper 2 positive 10 to the power minus 4 molar plus 2 electrons will give copper in solid. This oxidation half cell was done at anode, while the reduction half cell is at cathode as per the loan also. And the E naught of copper 2 positive oblique copper 0.34 and E naught of Mg2 positive oblique Mg will be given to you in the paper as minus 2.36. The number of electron change here are nothing but it is 2. So if I'll write down the Nernst equation, that is E of the cell is equal to E naught of the cell minus 0.0591 n log C to the power C, D to the power D, A to the power A, B to the power B. That means what I'm going to do right now is I will separately calculate that this E naught of the cell. Of course, E naught of the cell is E naught of cathode minus E naught of anode. And cathode pay we have copper. So E naught of copper 2 positive oblique copper minus E naught of Mg2 positive oblique Mg, which is at anode. The value of copper 2 positive is 0.34. So I'll put down the value of 0.34 minus 2.36. So it comes out to be 2.70. So E naught of the cell comes out to be 2.70. So I'm going to put the value here as 2.70 volt. This is the value 2.70 volt. Then minus 0.0591 divided by 2 because number of electron change are 2 log. See, I told you this is oxidation or react product divided by reactants. If I am not wrong, this copper in solid is 1 and here magnesium in solid is 1. So this will be 10 ki power minus 3, the one which is being oxidized divided by 1 which is being reduced 10 ki power minus 4. So if I put down these values and we'll try to solve it, this cancels out to give you 0.0591 divided by 2 is nothing but it is 0.0295. And once I'll shift this here log 10, we know that log 10 is nothing but it is how much? 1. So 2.70 minus 0.0295 log 10 is 1. So if I solve 2.7000 and of course 0.0295, this is suppose the value given to me. Now what of course I'll do 9 9 and this is 10. So 507.2.67. You can even write 2.67 volt or you can write 2.68 volt, one and only the same thing. So you will be getting full marks for writing 2.6705 or 2.68 volt also will do. This is one question that we have done now. Let's take up the next question now. And this question is Rn in solid, phase change, Fe2 positive. Here, of course, 1, 2, 3. This is again 10 ki power minus 3 molar. H positive 1 molar hydrogen gas and this platinum as such is inert electrode. This question was asked in CBSE 2013. Now, if I'll write down the oxidation half cell, of course, which is at anode, iron in solid goes into Rn2 positive. So iron in solid goes to Fe2 positive 10 ki power minus 3 molar plus 2 electrons. This is at anode. And reduction half cell may this is H positive. So 2H positive will give you will gain 2 electrons to become hydrogen in gaseous state. Of course, that gaseous state is nothing but it is 1 atm. Now, this is at cathode. If I'll write down the overall equation, my overall equation is when these 2 electrons will cancel out, iron in solid plus twice of H positive 1 molar because this is 1 molar only concentration of H positive, that is giving Fe2 positive 10 ki power minus 3 molar plus hydrogen gas. As I said, number of electron change are nothing but they are 2. Now, if I'll write down E of the cell, here also the value of E naught of the Fe2 positive oblique Fe will be given to you in the board whenever they ask this question. And hydrogen value, as you know, is a of course standard hydrogen electrode has a value of 0. So whether it is provided in the exam or not will not make any difference as such to you because it is if the value is not given, that means it should be taken as 0. Now E of the cell is E naught of the cell minus 0.0591 n log, again the formula written. Now as I said, I always suggest to calculate E naught of the cell separately. That is E naught of the cell is equal to E naught of cathode minus E naught of anode. That is, cathode pe we have hydrogen minus 0.44 is the iron key value. So it comes out to be 0.44 volt. Now, if I'll try to put down E of the cell is 0.044 minus 0.0591 2, because I'm now directly applying now log this hydrogen has a pressure of 1 atm, so I will ignore this. Fe2 plus 10 ki power minus 3 molar, so this is 10 ki power minus 3 molar. This divided by this iron in solid is always 1, so I'm going to leave it. Now the most important is H positive ki power 2 will be raised, so I'll raise the power of H positive as 2. So this is the power, that is 2 will be raised. Although here the value of H positive is 1 molar, so will not make any difference as such, but still I have written here. Now this becomes 0.044. If you divide this, this is 0.0295. Now I thought I have already told you log m ki power n is nothing but it is n log m. So this minus 3 will go here in front. So minus 3 come in front, and this is log 10. We know that log 10 is nothing but it is how much? 1. So if I solve this question now, this is 0.044 minus into minus plus 0.0295 into 3. And of course, I will multiply this, and then after I'll add in order to give you the value, whatever the answer will be. You can actually check by solving it. I have already solved all these questions for you in the notes itself. What I have done, the answer will be 0.529 volt. So I can write here answer is 0.529 volt. Now there is another question which was asked in the same way in CBSE 2015. The question is same. The only thing is, in the above question, here the concentration of H positive was there. Of course, in the previous question, the concentration of H positive was given 1 molar. In this question, it is given 0.01 molar. So that means if it is 0.01 molar, that means it is 10 ki power minus 2 molar. If I'll shift this, it comes out to be how much? 10 ki power minus 2 molar. So the only difference here is that if I'll solve, E of the cell is equal to 0.44 minus 0.0591 2 log 10 ki power minus 3. Here it will be 10 ki power minus 2 but raised to the power 2. Raised to the power 2 because I have already told you, if you see the equation, the stoichiometric power will be raised. Here it is 2. So H positive ki power 2 should be raised, as I have done it here also, if you can see. So I'll write 10 ki power minus 2 ki power 2. That is of course 10 ki power minus 4. And once it goes up, it becomes 10 ki power plus 10 ki power 4. And of course that becomes log 10. Log 10 is 1. So again 0.044. This time 0.44000. May say you have to subtract 0.2950. So here, if I'll try to subtract, right, this is 3, this is 9, this is 9, this is 10. Sorry, the last one is 10, right? So this is 10. So 5, this is 0, 1, 4.0, 0.415, 0.4105 volt will be your answer. Now we will take up the next question, beta. Of course, the next question is this. This is also third question of NCERT only. Sn in solid is giving Sn2 positive 0.050 molar oblique H positive 0.02 molar oblique H2, and platinum, of course, as I said, is an inert electrode, so we don't have to consider it. Again, if I'll apply the same formula, Sn goes to Sn2 positive. So oxidation half cell will be Sn in solid Sn2 positive. This can be written as 5 into 10 ki power minus 2 molar plus 2 electrons. This is at anode. And here 1, 2. That means 2H positive will be written 2 into 10 ki power minus 2 molar plus 2 electrons will give hydrogen. This is at cathode. That was at anode. So overall equation you can easily write now. I thought I always used to say it in class 11th also. It's better to remember the value of log 2, log 3, log 5. But although these all values will be given in the board exam, that log 2 is 0.3010, log 3 is 0.4771, log 5 is 0.6990, log 7 is 0.8451. Now again, the value of E naught of SN2 plus 2 SN will be given to you. On hydrogen, of course, is 0 only, because that is a reference electrode, minus 0.14 volt for 10. So E naught will of the cell will be E naught of cathode minus E naught of anode. Hydrogen minus 10 key value is minus 0.14, so it comes out to 0.14. Now if I'll try to put down the values, 0.14 minus 0.0591 divided by 2 log. Now, of course, product, I told you product divided by reactant. So here this is 1. Now this is 5 into 10 ki power minus 2, and this is also 1. So I'm going to leave this. H positive की power 2, यानी 2 into 10 की power minus 2 की power 2 beta raise हो गया. Now I always used to say कि it's better that I can solve this separately. So if I'll try to solve this, this is 5 into 10 ki power minus 2 divided by 4 into 10 ki power minus 4. So if I shift this above, this is 5 into 10 ki power 2 divided by 4. I thought, if I'm not wrong, it is 500 divided by 4. And that 500 divided by 4 is nothing but it is 125. So 125 can be written in terms of log 5, and that is, if it is 0.14 minus 0.0295 log 5 ki power cube. If it is log 125, it is 5 ki power cube. As I've already told you, log m ki power n is nothing but it is n log m. So that means this n will come in front. So this 3 will come in front over here. So 3 into 0.0295. So again, if I'll solve, I will be able to get the answer. That is, of course, as I said, I have already done this question also for you, and that comes out to be 0.078. So this answer is 0.014 minus, I thought 0.078 will be the answer for this. If I'll solve this whole question, that is 0.078. So answer will be 0.078. This is the answer that I will be getting, right? Now we will take up another question, and that question is, of course, as I said, this is the fourth question of exercise 3.5, fourth part. That is platinum in solid, Br2, liquid, bromide 0.010 molar, salt bridge, H positive, oblique H2 in gas. Now I have seen most of the time people used to say that they are not able to understand this question. This question is not incorrect as such. The only point that we have to take care is that here the bromide will be converted into bromine, because as we know, on the left hand side we always have oxidation, and on the right hand side we always have reduction. So that's why my oxidation half cell will be twice of bromide, which is of course 1 to 10 ki power minus 2 molar, will give you bromine, of course, in liquid, plus 2 electron. This is at anode. This is at anode, oxidation reaction. And 2H positive plus 2 electrons will give hydrogen in gas. This reaction is of course at cathode. Now the most important thing here is, if I'll write down the overall equation, the number of electron change need not to tell you is nothing but it is 2. And if I cancel out these 2 electrons, my overall equation will become what? That is twice of Br negative, of course 10 ki power minus 2 molar, plus 2H positive. Of course, we have aqueous, that is 1, 2, 3 into 10 ki power minus 2 molar will give you Br2 in liquid, plus of course hydrogen gas. This is what we are going to get. Now if I'll try to see the value of what do you call your reaction, or for hydrogen, so we know the value. For your bromide, the value is minus 1.08. I repeat, the value of bromide will be minus 1.0 plus 1.08, right? So if I try to solve this question now by applying the Nernst equation, I can solve. Let me just try the Nernst equation. But before that, E naught of the cell will be E naught of cathode minus E naught of anode. Of course, E naught of cathode is nothing but it is hydrogen. Hydrogen has a value of 0. And as I said, bromide has a value of 1.08, which will be, of course, given in the exam. So I'll write 1.08 minus 1.08 volt will be E naught of the cell. Then, of course, I'll try to put down in E of the cell minus 1.08 minus 0.0591. Of course, number of electron change, as I said, is 2 log. Now here both the things product are 1 because in the gaseous state, and of course reactants are nothing but they are given 10 ki power minus 2 to the power 2 because I was talking about bromide, and then of course 3 into 10 ki power minus 2 ki power be 2. This is what we will be able to. Now, as I said so many times, I always emphasize that it's better that I can solve this equation 3 into 10 की पावर माइनस 2 मोलर इक्वेशन जो यहाँ पर राइट हैंड साइड पे आ रहा है लॉग, इसको कहीं दाएं बाएं सॉल्व कर लिया जाए. ठीक है, दिस इज व्हाट आई ऑलवेज यूज टू से. सो this part is 1 divided by 10 की पावर minus 4 and then 9 into 10 की पावर minus 4 because 3 3 are 9 and 10 minus 2 is. So I thought I can write this as 1 9 into 10 ki power minus 8. This is what I can write. Now what I can do here is minus 1.08 minus 0.0295. What I can do right now is log 9 into 10 ki power minus 8, and I'll put a plus sign because I'll reciprocal it and I'll put a plus sign. ठीक है, माइनस इंटू माइनस ये 1.08. अब 0.0295. This can be solved as usual. How? I'll write log a bracket 3 की power whole square 9 plus log 10 की power minus 8. This is how I'll solve, because I thought I have told you log m into n is log m plus beta log n. We know that. So if it is log m plus log n, it is log 3 की power 2 plus log 10 की power minus 8. अब now 9 को मैंने 3 की power 2 लिखा minus 1.08 plus 0.0295. Then this 2 comes in front, 2 log 3 minus 8 log 10. log 3 की वैल्यू ऑलरेडी आपको पता है क्या होती है, 0.4771. So I'll write here 2 into 0.4771 minus 8 log 10 हमें मालूम है 1 है. So if I'll solve this equation, of course whatever I'll get here, multiply this in volt, I'll be able to get the answer. I hope this is also clear to you. But our next question that we are going to take up right now is where the number of electron change will be different. अभी तक आपने जो भी किया, you have seen that the number of electron change were almost same. That means 2 or 2 electron, 3 or 3 electron. But now you can see here, when we have this question, you can clearly see that aluminium has got 3 electrons while nickel will have 2 electrons. But there is another point, beta. I have not been given salt bridge here. The most important thing right now is that I've been given and people used to say and matlab salt bridge hota hai. They are absolutely incorrect, beta. That is not basically what a salt bridge. What I want to tell you is I have to decide on the basis of E naught value. E naught of Ni2 positive oblique N minus 0.25 volt. E naught of aluminum minus 1.66. I have already taught this thing to you, and that is anything which has a negative value is always taken at anode or is attached at the anode to make the reaction spontaneous. And if anything has a positive value, is always attached at the cathode. So considering this, aluminum will be anode, right? While my nickel will be at cathode. So of course, this is a merely a coincidence that aluminum is on the left hand side while nickel is on the right hand side. So if even if you consider that we have and ke badle a salt bridge, your things will of course will do, or you will be able to solve the question. Oxidation half cell will be what? Aluminum in solid goes aluminum 3 positive 10 ki power minus 3 molar plus 3 electrons. This reaction is going on at anode, oxidation at anode. In the same way, nickel 2 positive 5 into 10 ki power minus 3 molar, 1 molar, sorry, 5 into 10 ki power minus 1 molar, you can see here, plus 2 electrons will give nickel in solid. But the number of electron change are not same. So this equation has to be multiplied by 2. This has to be multiplied by 3. So the overall equation will become now twice of aluminum in solid plus thrice of nickel 2 positive. Of course, 5 into 10 ki power minus 1 molar will give you twice of Al3 positive, 10 ki power minus 3 molar plus thrice of nickel in solid. Here the number of electron change are 6. Here the number of electron change are 6. So if I'll solve this equation now, again, as I said, it's better to calculate E naught of the cell separately. So if I calculate E naught of cathode minus E naught of anode, cathode pe we have nickel. The value of nickel is minus 0.25. Minus 0.25. And then this is minus 1.66, of course, volt. So minus 0.25 plus 1.66 volt, right? What I have done here is I have actually put down in this only. That means here, but this comes out to be 1.41 volt. Now, as I said, E naught of cathode minus E naught of anode minus 2.303 RT by NF log. This nickel in solid is 1 and aluminium 3 positive की पावर 2 रेज हो जाएगा डिवाइडेड बाय एल्यूमिनियम इन सॉलिड इज 1 एट द बॉटम, और ये जो डिनोमिनेटर में निकल की पावर Ni2 प्लस की पावर क्या आएगा 3 आ जाएगा. सो Ni2 पॉजिटिव की पावर 3. नाउ एज आई सेड आई हैव ऑलरेडी सॉल्व दिस पार्ट which is 1.1 volt minus 0.0591. Of course, the number of electron change are 6 here because here number of electron change 6 log. This is aluminium is how much 10 की power minus 3 की power 2 यानी 10 की power minus 6, and this is 5 into 10 की power minus 1 की power 3. So 5 का whole cube 125 into 10 की power minus 3. So of course again I'll solve this somewhere, right? So 10 की power minus 3 if this goes above divided by 125. Now we know that log m by n, I repeat, log m by n is nothing but it is log m minus log n. So log m minus log n. Again this minus 3 will come forward, minus 3 log 10 1 हो गया, minus ये 3 बाहर आ जाएगा, 3 into log 5. I repeat, if you say I can write down this step in a more appropriate way, and that is this can be written as minus 3 log 10 minus 3 log 5. So minus 3 log 10 1 and 3 log 5 is 0.6990. So I'll solve this. Whatever value I'm going to get, I'll try to put this value here, and of course I'll solve it. I'll be able to get the answer in volt. I still remember it comes out to be 1.46 volt. So I hope now you can solve this question.